Okay, good afternoon, everyone. So today we will still discussing about the friction in the fluid flow. Before I continue the lecture, maybe I will a bit refreshing the discussion that we already have in our last lecture. So this one. So basically, our last discussion. In our last discussion, we already. Hey, why cannot edit this one? Sorry, just a minute. Okay, there's some problem with the previous PowerPoint. I don't know why. Okay, from this one. Okay, from our previous discussion, we already know the parameters about the EF. This is the friction heat or friction energy, but you quantify it with the unit of energy over mass. So if we are using small EF or the specific friction energy, when we put into the Bernoulli equation, we need to use the unit for other parameters as energy over mass as well. So it means for the pressure, it will be this one. And then for the potential energy, it will be G times Z. And then for the kinetic energy, it will be half times velocity square. And then for the other point, it will be the same. Okay, so if you put EF on the left side, it should be with the minus sign. But if you put EF on the right side, it should be plus sign. Okay, then how to calculate EF? Basically, last time we already know we can calculate EF by calculating the friction factor or FF. FF, if we're using, there will be two types of value, right? What is called the fanning friction factor or Moody friction factor. What is the difference? The difference is only Moody friction factor is 4 times FF or fanning friction factor because it comes from this equation. So you just put 4 times fanning friction factor together. So if you are using fanning friction factor, use this equation to calculate EF. But if are using Moody friction factor, use this equation. There will be no 4 here, right? So please be careful whether you are using which friction factor. Okay, friction factor can be classified into the laminar and turbulent calculation. So for the laminar calculation, for laminar flow calculation, the friction factor will be just inversely proportional to the Reynolds number. Remember again, Reynolds number is this one. So for the Moody, the Moody friction factor will also inversely proportional by the Reynolds number, just 16 multiplied by 4. Okay, how about the turbulent flow? For the turbulent flow, beside Reynolds number, the friction factor will also function of relative surface roughness. The epsilon is the inner roughness of the pipe, and d is the inner diameters. So for the turbulent calculation, you can use this one, the empirical equation, but for the simplification method, you can use the graph. So before you use the graph, I'll remind you again, just check whether the graph is for the fanning or for the Moody friction factor. So from the graph, you can see that the the friction factor for the turbulent flow will be increasing. Ff will be increased if epsilon over d is increased, this one. But if Reynolds number is increasing, Ff will be decreasing until certain point when the friction factor is constant. So it is represented by the straight line on the graph. Yeah, that's how you can calculate EF. So first you find out the FF. FF will be function of Reynolds number, or for the turbulent will be also function of epsilon over d, and then you calculate EF, and then you put into the Bernoulli. Okay, and please remember again, in calculating Reynolds number, the diameter will be inner diameter. So if if the data is only the nominal size and also the scheduled number, you need to check from the textbook or the data what is the value of inner diameter or inside diameters. If you know the thickness, so the inside diameters will be outside diameters 2 times thickness. Okay, until this point, is there any question? Okay, no question, right? Okay, I think we have already discussed this one, but the most that you need to remember or you need to understand is this equation. So basically, this is the Bernoulli equation with including the EF. Remember again, Bernoulli is the analysis of total energy, and you comparing that the total energy at one point will be the same as the total energy at the other point. But now you know, you already know the parameters EF. So you need to calculate this value of EF as well. Okay. Do you have any question until this point? I think should be clear enough. So now we'll see this exercise. Please don't see the solution because the solution is a bit incorrect. So at this exercise, we will have two tanks. Maybe I'll draw here. Tank A to tank B. So this is tank A, this is tank B. And then these two tanks is connected by a straight pipelines with the length of 200 meters. The pipe here is 3-inch nominal and the schedule 40. So please be careful. The data in the pipe size is in nominal size. Okay, and then oil is transported from tank A to tank B with the flow rate of 200 liter per minute. The oil density is 850 kilogram per cubic meters. And then oil viscosity is 45 centipoise. Okay, tank A is closed and tank B is open to the atmosphere, and the level of oil in the tank A is the same as the oil in the tank B. So suppose you have this level and you have this level, the level of the oil in both tank are the same. Okay, the question is this one atmospheric. And please calculate PA. Okay, uh, please take out a piece of paper and pen with you or pencil, and then try to do this exercise. First, what you need to do? How can you calculate the pressure at point A? What kind of equation that you need to derive or you need to use? Hello? Okay, I'll ask then. Adril Surya? Yeah, can you answer? No answer. Alisa Kinanti?
Yes, sir.
Okay. So in order to calculate the pressure at the top of the oil in the tank A, so at this one, what kind of equation that you need?
Um, can we use the Bernoulli equation?
Yes, correct. So you need to derive the equation Bernoulli between which point?
Um, A
A is here, okay, and
and B.
B is where?
On the right.
Yeah, I mean which at the bottom or at the top? Which one do you choose? The point at the top of the oil at the tank B or at the bottom of the tank B?
I think at the top of tank B.
Why? Okay, this is B.
Because we're finding the pressure on top of the A, so I think we also have to compare it with the top pressure from B.
Okay, that's one, and that's one reason, and the other will be the at the top of the oil in the tank B, the pressure is atmospheric, right? So you know the value. So the total energy at A, A means top point, will be the same as the total energy at B. B is at the top point as well. So please don't forget this one. Sorry. This one, right? But you know EF. You need to put EF. You can put whether on the left or on the right. For this one, I put on the left. So this one minus EF. Okay. Then what did you do? What you need to do to calculate EF? How to calculate EF? You need to quantify first the value of friction energy in the unit of specific energy. That's why all the equation, all the energy, whether it's pressure, potential, kinetic, and also the friction, all will be all in the unit of specific energy, joule per kilograms. How to calculate EF? Or where the EF comes from the system. Are you?
Sir,
Yes. Okay. Can you
is it from like when you transport the oil?
Yeah. So the friction comes from the transporting the oil in the pipeline, right? The 200 meters pipeline. So how to calculate EF? You can use mana dari persamaannya? Okay, you can use this equation to calculate EF. Yeah, you can use this equation. So EF will be, okay, just a minute. I have a call that I need to answer. Okay, sorry. Oops, the picture is still there. Okay, okay. EF will be this one, right? 4 times L per D times friction factor times half times velocity square. So you need to L per D over friction factor times half times square. Okay, which data that you already have? Okay, from the question, mentioned in this slide, which data that you already have? Do you have the value of L?
Yes, sir, we have the value of L.
Okay, the length is known, is 200 meters. Do you have the value of D? So L is 200 meters. Do you have the value of D? What is D here?
Is it diameter, sir?
Is it diameters? It is diameters, but which diameters? Diameters of what?
Of the pipe, sir?
Of the pipe. Outside or inside?
Inside?
Inside. But the the soal just stated 3-inch schedule 40, right? So this is still in the nominal diameters. So you have to check what is the inner or the inside diameters of this kind of pipe. Bisa dapat dari mana? Where you can get it from? You can get from the data. So can you check for pipe with 3 inches schedule 40, what is the inside diameters? Ada yang punya buku teksnya? Do you have?
It's 77.92 millimeters, sir. The inner diameter. 92.
77.92 millimeters. Let's be careful with the unit, right? So you need to later to convert it into standard. Okay, you have the D1. And then do you have the velocity? This is the linear velocity. So should be in meter per second. So you have this one, right? This is the volumetric flow rate, liter per minute. This is the volumetric flow rate. How to convert it into the linear velocity?
Divide by area, sir?
Yes. So you need to calculate what is the velocity in the unit of meter per second. Can you calculate? So you, from the inside diameters, 77.92 millimeters, but please convert it to meters. And then you calculate the area and then the volumetric flow rate, but you need to convert the volumetric flow rate. So you volumetric flow rate should be in this one, cubic meters per second. Then you divide it by the area. The area should be in meter square. Oke, coba dihitung. Sudah dapat berapa U-nya? What is the value of the linear velocity? Convert first 200 liter per minute become cubic meters per second. Then for the diameters, please convert millimeters into meters and then calculate the area. Then divide the volumetric flow rate divided by area, then you can get the velocity. Berapa? Ayo coba dihitung. Do you have the answer for the velocity?
Sir, I
Yes, sir.
got
Mm-hmm.
It's okay. Hal, you can go first.
okay. I got 0.698.
0.698. How about the others? Is the answer is the same?
Yeah, got the same, sir.
Okay. Now you have the value for the velocity. Then how to get the friction factor? For the friction factor, you need to classify first whether it's laminar or turbulent. So you need to calculate the Reynolds number. You already got the diameter value, you already got the velocity value. The density is 850 kilograms per cubic meters, is already in standard, but for the viscosity is in centipoise. So you need to change into the standard unit. You need to convert it first. So 45 centipoise will be 0.045. So please calculate how much is the Reynolds number. Using the inside diameters, but please convert it into all the standard unit, right? Density times diameters times velocity divided by the viscosity. How much is the value of Reynolds number?
Sir, mau nanya, sir.
Yes.
Itu viscosity standard unitnya apa, sir?
Pascal second.
Oke.
So in standard unit, it will be 0.045 Pascal second. So how much is the Reynolds number?
I got 1027.33, sir.
27. Okay, 0.3. How about the others? Apakah sama? Do you have the same results?
I got 1027.1.
Okay. So this one is laminar or turbulent? It should
It's
be
laminar, sir.
laminar, right? So FF should be this one. You can calculate the value and then you can calculate the EF. Okay, can you do the calculation? Calculate the friction factor and then the friction factor put into the EF calculation. How much? Sudah dapat?
For the EF, I got 38.95, sir.
EF 38.95
95.
joule per kilogram. Okay, so you put it into this equation. PA divided by the density times GZA times UA quadrat minus EF will be PB divided by rho GZB plus half UB square. But now you need to be careful. Previously, when you are calculating the EF, you see or you analyze the part from the transporting pipe. But now, when you analyze the Bernoulli from point A, which is at the top point of the oil in tank A, and point B, top point of the oil at tank B, you only comparing these two points. So this one, which parameters that you can simplify? In the Bernoulli equation?
The height, sir?
Okay, because
They're the same height?
yes, ZA should be same as ZB, so you can the height can be cancelled out. Okay, and for the velocity, how about velocity at point A and velocity at point B? Because the head is the same and there is no movement of the oil in both tanks, so we can say that the velocity at point A is 0 and the velocity at point B is also 0. So you need, and this one is atmospheric. Atmospheric means, do you still remember the value? 1 atm equals in standard unit. Berapa nilai tekanan atmosferik kalau 1 atm dengan satuan standar? How much? In Pascal, the standard unit of pressure will be Pascal.
$101,000 something something.
Okay, this one, right? Okay, so you can calculate the pressure at point A. Please calculate how much the pressure at point A, at the top of the tank. ketemu berapa? How much?
Sir,
Yep.
I got 101,363.95.
Sorry again. PA will be 100.
101,363.95.
How come it's very the atmospheric is 101,325, right? So just
Yes, sir.
divide it by density, and then plus this one, and then multiply it by the density. Is it this much?
Yes, sir. Yeah.
Okay. How about the others? If the answer is the same, then should be okay. Yang lain apakah hasilnya sama? So the density is 850 kilogram per cubic meters. Sama? The other student, please.
Sir, I got the different answer now, sir.
Sorry?
I got the different answer now, sir.
How come?
Salah di itu, sir, in the parentheses. Di kurungnya, sir.
Okay. So how much the pressure?
I got 134,432.5.
432.
34,432, yeah. 0.5.
Yes, just a minute. Can you repeat? 134.
134,432.5.
Okay. Pascal, right? Okay. Okay. For the others, please check your calculation. So the atmospheric pressure at 101,325 Pascal divide by 850, and then the value should be add with the EF, the 38.95 joule per kilograms, then multiply it by 850. Then you got the PA. Okay, I'm still waiting for the result from other student.
I got the same, sir.
134 something, right?
Yes.
Okay, how about the other? I hope the other doing the calculation as well. Okay, while waiting, just let me repeat again. So for this system, basically for analyzing the Bernoulli equation, you are comparing the 2 points. Remember again, for Bernoulli, it should be the steady state condition, right? So at point A at the top and point B at the top, at the steady state condition, the total energy should be the same. Then you can derive the formula for the Bernoulli equation by putting the EF. Then you do the calculation of EF. EF is the function of friction factor. You need to calculate the friction factor first. For friction factor calculation, you need to check the Reynolds number, whether it's laminar or turbulent. If laminar, like in this exercise, then you can directly calculate the friction factor. But if you found out that the the Reynolds number is the turbulent, then you need to find the value of friction factor from the graph. So you need to use the surface roughness. For this case, because the Reynolds number is laminar, then no need to check the graph, no need to use the epsilon over d value. You just calculate 16 over Reynolds number, you get the friction factor, then you calculate EF. After you got EF, you put EF in the Bernoulli. That's all. Okay, do you have any question, or do you still have doubts or any question related to the exercise? The most important is you need to check again the units. You need to use one consistent unit. For example, if you are using in standard, then all the units should be converted into standard unit. Then you can do the calculation. Okay, any question? Ada pertanyaan? Okay, if there is no question, then we will continue our lecture on Thursday. Okay, good afternoon. See you and bye-bye.